Good day, everyone. My name is Ruben Flores, and welcome back to my YouTube channel. For today, this will be just a continuation video and brief continuation video about my previous videos, and it is all about the differentiation and integration of power series. So, properties of functions defined by power series. If the function f of x is equal to the summation of a sub n, quantity of x minus c raised to n as n is equal to 0 and approaches to infinity, we came up with a sub 0 plus a sub 1, quantity of x minus c, plus a sub 2, quantity of x minus c squared, plus a sub 3, quantity of x minus c cubed, and so on, has a radius of convergence of r is greater than 0. Then the interval is, we have the quantity of c minus r, or real numbers, com, comma c plus r. F is differentiable and pure are therefore continuous. Moreover, the derivative and antiderivative of f are as follows. So if this derivative of x is equals to the summation of n a sub n, quantity of x minus c raised to n minus 1, as n is equal to 1 approaches to infinity, we have this a sub 1 plus 2a sub 2, quantity of x minus c, plus 3a sub 3, quantity of x minus c squared, and so on. However, the integral or the antiderivative would be the integral of f of x dx is equal to c plus the summation of a sub n is a sub n, quantity of x minus c n plus 1 all over n plus 1, and that will be equal to c plus a sub 0, quantity of x minus c plus a sub 1 to the quantity of x minus c squared all over 2 plus a sub 2 to the quantity of x minus c cubed all over 3, and so on. The radius of convergence of the series obtained by differentiating and integrating of power series is the same as that the original power series. The interval of convergence, however, may differ as a result of the behavior at the endpoints. So we have to consider the function given by the f of x, the summation of x raised to n all over n, as n is equal to 1 approaches to infinity. So we came up with x plus x squared all over 2 plus x cubed all over 3 plus and so on. Find the interval of convergence for rather each of the following. So we have this integral of f of x dx, the function of x, of f prime of x. By the theorem 9.21, you have the f prime of x. We came up with the summation of x raised to n minus 1 as n is equal to 1 approaches to infinity. So we came up with 1 plus x squared plus x cubed plus and so on. And for the integral or integration of f of x dx, antiderivative rather, is equal to c plus the summation of x raised to n plus 1 all over n, the quantity of n plus 1, as n is equal to 1 approaches to infinity, we came up with c plus x squared all over 1.2 or 2 factorial plus x cubed all over 2 times 3 plus x squared over 3 times 4, and so on. By the ratio test, you can show that each series has a radius of convergence of r is equal to 1. Considering the interval of negative 1 and 1, you have the following. For the antiderivative of f of x dx, the series would be negative 1 and 1. Fixed convergence for x is equal to positive or negative 1. And the interval of convergence negative 1 over 1 is seen in the figure below. For the f of x, we came up with xn raised to n as n is equal to 1 approaches to infinity. The interval of convergence is negative 1 but continuous in 1. So converges for x1, converges for x is equal to negative 1 and diverges for x is equal to 1. So its interval of convergence is this, negative 1 and 1, which is shown in the figure below. For f prime of x, the series looks like this: x raised to a negative n minus 1, where n is equals to 1. The interval convergence is negative 1 and 1. Diverges for x, both x either positive negative and its interval convergence converges is -1 and 1. And that will be all. Thank you.